Hi, everyone. Today we are learning about the basics of probability. So, an event is any collection of results or outcomes from some procedure. So, the probability of event A is going to be the probability of event A equals the number of times that A happens over the total sample space or the number of trials. The complement is going to be all outcomes in which event A does not occur. And we write the complement of event A as P of not A, the probability of not A. And this little symbol right here indicates not A. And the relationship between an event and the complement of an event is that if you add the probability of an event occurring to its complement, they should equal 1. So let's talk about some notation we're going to be using in this unit. P is probability. A is the specific event, right? So we're saying like P is probability, A is the specific event, and then P of A is going to be the probability that A happens. P of A not is going to be the complement of A, or basically the probability that A doesn't happen. And then NA is going to be the number in A, number of times the event happens. And NU is going to be the size of the sample space or total number of possible outcomes or trials. These are other ways that you could hear it said. Let's look at an example. We have event A is rolling a 4 on a fair die. Let's calculate the probability of event A occurring. Well, a die has 6 sides. One of them is a 4, so we would say 1 of 6. Let's calculate the probability of A not happening. That means you could roll a 1, a 2, a 3, a 5, a 6. There are 5 other possible outcomes that you could get if you're trying to get not A or not 4. Let's calculate the probability of B. Event B is rolling a 3 on a fair die. Let's compare this to the probability of A. Are these equally likely outcomes? Well, the probability of event B is going to be the probability of rolling a 3. That's going to be 1 out of 6. And are these equally likely outcomes? Yes, they have the same probability of occurring. Now let's talk about sample spaces. So a sample space is a complete list of all possible outcomes. And if you're ever trying to write out a sample space in order to figure out a problem, try to have a systematic way of writing it out. You'll see here. In example 1, it says, a doctor is delivering 3 babies in 3 separate births. List the sample space for all possible outcomes. Okay, so he's going to do 3 babies in 3 separate births, okay? So the probability or the list of total possible outcomes for each birth is going to be boy or girl, right? You have 1 or 2 things that it could be at birth. So we would list the sample space for 3 babies in 3 separate births by listing all possible combinations. So for the 3 births, we could have all boys, we could have boy, boy, girl, boy, girl, 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 boy, girl, boy, boy. Sounds like I'm gurgling. Boy, girl, boy, or girl, boy, girl. Okay? That is the list of all possible outcomes, aka the sample space. Now, it is a slow day in the hospital and the nurses are bored. They decide to place a bet on the probability of 2 boys and 1 girl. So that's 2 B's and 1 G. Highlight the desired outcomes in your sample space above, then calculate the probability of 2 boys and 1 girl. So we have probability of 2 boys, 1 girl. Let's try to find the number of times that happens, right? So the NA. So 2 boys, 1 girl. 2 boys, 1 girl, 2 boys, 1 girl. That's going to be happening 3 times out of however many things are in the sample space. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So are these equally likely outcomes, or are there equally likely outcomes for each birth? Yes. For each birth, you can have a B or a G. 1 out of 2. So these would have equally likely outcomes for each birth. Now, here's the big idea behind probability, right? Let's say that event is impossible. It's never going to happen. It will have a probability of 0. If an event has a probability of 1, it is certain that that event will always happen. If it has a probability of 0.5, sometimes we refer to this as a 50-50 chance. Okay? And all probabilities fall within this continuum because all probabilities must be greater than or equal to 0. Oops, hold on. I was trying to avoid to hit the cancel button and it was like making it weird. Okay, so I have 0. The probability of A must fall between 0 and 1, and that's just an inequality outlining that. So if we get closer to 1, a probability of 1, that means that that event is very likely. Whereas if we have a probability that's less than 0.5 and it keeps getting smaller and smaller and closer to 0, we would say that that event is unlikely. Okay, so this is just how you can gauge once you've got the probability number. Okay, what does it mean? What does a probability of 0.25 mean? It means it's probably a pretty unlikely event. It's closer to 0 than it is to a 50-50 chance. Now, there's two types of ways that I want you to think about probability. In experimental probability, we're talking about real data from a real sample. These events have occurred and we have compiled a list of all the outcomes that happened. Okay, we are analyzing real data. So for example, you have to flip a coin 10 times. 5 times you get heads. The experimental probability, aka the relative frequency of getting heads, is going to be 5 out of 10 or 1/2 or 0.5. These are all the ways that we can read it. In the same scenario above, flipping a coin 10 times, could you get a probability of 0.3? So could you get 3 heads in 10 flips? You sure could. Your experimental probability could certainly be 0.3. Well, could you get a probability of 1/2? Why or why not? Could you get 12 heads in 10 flips? No, absolutely not. That's why we can't ever have a probability that's greater than 1. Anything over 1 doesn't really make sense. You can't have 12 heads if you only flip the coin 10 times. Now let's talk about theoretical probability. We calculate the probability of an event occurring using theoretical probability, right? This is the probability that you use to make predictions or decisions. You use it to calculate expected occurrences. So if there are 128 kids in a class, and the probability of being absent is 0.1, what is the expected number of absent students on any given day? Well, we would just multiply 128 students by the probability of being absent, and we would get 12.8. You can't really have 12.8 absent kids, so I would probably round that to about 13 kids absent each day. And why would you want to calculate something like this? So that way attendance has an idea of how many people should be absent. Is today an outlier? Is today a crazy day? Why are so many people absent? We can use probability and especially theoretical probabilities to help us determine if this is a normal outcome, if this is something that usually happens or not. All right, different types of probability events. So the big idea here is that there are mainly 2 different types of probability events. You can have independent events. 2 events are independent if the fact that A occurs doesn't affect the probability of B occurring. Okay. So, for example, the event of the mail getting delivered is independent of the weather. If it's raining, I'm still going to get my mail. The mail is delivered, rain or shine. Whereas in a dependent event, the probability of the second event depends on the outcome of the first event. So, for instance, you draw a queen, yas, from a deck of cards, right? There are 4 queens in a deck of 52 cards. Now, this is in the first draw. What is the probability of getting a queen in the second draw? Well, I now have 3 queens left because I already picked one over here. And I only have 51 cards left because I already picked one over here. And we call this sampling without replacement. If I put the first queen back after getting 1 queen out of 52, then they would become independent events because then I still have a 4 chance out of 52 cards. But because I took 1 queen out and then I wanted to see what would happen after I took 1 queen out, these now become dependent events because the probability of the second event depends on the probability of the first event. So we're going to check your understanding down here, fill out these quick little questions and bring them to class with you the next time I see you. And we're going to see how you did with probability. Have a good day.